twisting, man. Everybody's feeling great. They're twisting, twisting.
Good evening and welcome back to a new episode of Che Neuro che fa. I'm very glad to welcome our first guest, Matteo. Welcome, Matteo. You can sit here with us. Matteo will explain to us his new neuroengineering project. Let's start from the beginning. How did you start with the project?
I'm very glad to be with you this evening. I work with my team on the evaluation of a clinical scale through deep learning algorithm to evaluate the joint attention that is a specific disorder of autistic people. The joint attention is the capability of sharing the attention with other people or other objects in the same environment.
Wow, it's a very interesting project, but tell us, how did you measure this joint attention value?
We refer to the early social communication scale, that is a clinical scale. And how we can see in this video is that the therapist is pointing some objects, some targets, and the patient, the child, has to look to those objects. Then we train a deep learning model that has to automatically recognize the object that the patient was looking at. We made the acquisition both with an robot and without as object in the scene. And we retrieve the data both of the patient and both for the therapist.
That's nice. Now, can you please tell us how did you go on with your project?
Obtaining the videos, we deleted some unusable data, and then we passed to the processing part, so to put manually the labels, the gaze structure, and the cropped images. So we put manually the labels, setting them with some numerical values. Then we extracted the gaze direction, and then we cropped the images, like only to obtain only the face.
And then, how did you use this obtained data?
Before starting the training, we divided our dataset into training, validation, and test. The training to train our model, the validation to choose the best parameters, and the test to evaluate our model performances. Then we pre-train a multi-layer perceptron model, giving it in input the labels and the gaze, a convolutional neural network giving it in input the labels and the cropped images, and then the merged model. And we obtain two metrics, an accuracy and a precision matrix, both for validation and test sets.
So, finally, which are your results?
We train our model that is a union of a multi-layer perceptron model and a convolutional neural network, some metrics for the acquisition without the robot, both for the test set and the validation. We can see the metrics that are accuracy and precision, with a mean like for accuracy of 0.86 and for the precision of 0.55. The other slide we can see for the acquisition with the robot, similar values of metrics, and we can say also that we have similar values of metrics between the validation and test set, so our model is not like sensitive to a specific data set.
Well, I can see your results are really promising. Which are the future perspectives in your opinion?
Our model will be able to analyze a greater amount of data respect to what a human can do in the same amount of time, and to have a better reproducibility, to detect the intra and inter-therapist errors, to evaluate longitudinally the same child, or to compare different treatments.
Okay, I think we finished, so thank you so much for your interesting presentation.
Twisting, man. Everybody's feeling great. They're twisting, twisting the night away.